A very good morning, students. Today in GIS webinar number 7, we are going to see what are the data models available in GIS. And before that, we will see a revision of the second unit which we have seen so far. And then we will move on to today's topic, the ER diagrams and spatial data models. Okay. So far in last webinar, we have completed what is database structures and what is relational database management system and what is object-oriented database management system, and what are the advantages and disadvantages of both relational as well as object-oriented. And today we will have a revision of that, and we will see the comparison of both relational and object-oriented model. And then we will move on to the ER diagrams and spatial data models. Okay. So for today's webinar session, this is your puzzle. You can note it down or you can take a screenshot. At the end of the first session, we will be discussing the answers. Okay. We'll move on to the next slide. Okay. So we will start with our revision. So in last class, we have started with our second unit. In second unit, we have seen the basics of what is the data and how the data is being converted into an information, okay, and how that information is being processed, okay, how that information is being processed and how actually attribute data works. Okay, in first unit, we have been seeing what is the spatial data and what is the attribute data. So in this unit, we have seen in depth about what is an attribute data and how these data are being stored in the DBMS process and all, etc. And before starting with the revision, okay, so I would like to give a small brush up about what is a data structure and what is the types of data structure, because in the upcoming topics we will be seeing terms like raster data structure and vector data structure. So before going through those topics, I'll just give you a brief about what is a data structure. Okay. In normal words, this is the outline tree of the various types of data structures available so far. Okay. So in a data structure, why we are using a data structure is to easy arrangement of data in such a way that we can retrieve our data in a fast manner. Okay. So for example, if we have a data or if we have a collection of repository of data, like for example, the entire name list of the students of RMK Engineering College. If it is not in an ordered manner, if the names are shuffled, okay, then it is very hard to find a particular data, right? So that's why we follow a data structure. So in a data structure, in the sense, if for example, in the same example, in a student database, if there is no alignment, it will be a huge problem. So if there is an alignment, according to register number, if the number is aligned from ascending order, okay, then we can easily find out that person and the detail of the required person. Okay, so that is the power of data structure. Okay, so here data structure is generally classified into two segments. One is primitive data structure and another one is non-primitive data structure. Primitive data structure is the one which we are using in the programming languages, which is very basic and very Boolean. Okay, and non-primitive data structures are the one we have been studying so far in your second year, I guess so. So in data structures, the common two terms are, non-primitive data structures, the common two terms are linear data structure and non-linear data structure. The name itself specifies as the meaning. Linear in the sense it has some order. Okay, it is linear. It is ascending or descending, but it has some order. Non-linear in the sense it is not linear, it is not sequential. Okay, it is not in a proper order format. Okay. So examples for those linears are static and dynamic process. Okay. So whereas in static linear data structure, the only example is array. So array is also a data structure. So this part is very, very important because this part only we are going to discuss in this database structure. Okay. So like for example, you know that a database is a collection of rows and columns. So in the rows and columns, we have a combination of two-dimensional array. Okay, we can represent a tabular column as a two-dimensional array. So what's going on is, so this static linear data structure is being implemented in attribute data in relational database management system. Okay, And the other type is dynamic linear data structure, dynamic linear non-primitive data structure. So that has been segregated into list ADT, stack ADT, and queue ADT actually. Okay. So when that you will be having the various linked list operations, etc., etc. Okay. And moving on to the non-linear data structure, you will be having trees and graphs where it doesn't have a proper alignment, but it has some structured value. Okay. But it is not in a linear or sequential manner. It is very random and it is non-linear. Okay. So this is about the data structure. And the various primitive data structures which we have seen, which I have told in the previous slide, is integer, floating variable, double integer, character, and boolean. So these are the way. Sainath, I think you should be very patient, and at the end of the first session we can discuss the answer. Okay, and that is secondary, and this is priority first. Okay, so you can I appreciate your effort, but we will discuss the answers in the end of the first session. Okay, thank you. And in primitive data structure, integer, float, double character, boolean, these are the very basic primitive data structure which we are using in the programming languages. Okay. And we have seen about how a database is being represented, and what is a field, what is a record, what is an entity. So in conclusion, we came that a single column is represented as a field or an attribute. Okay, attribute is nothing but a one of the character or one of the features of the spatial data or objects of the spatial data. Okay. And one complete row is said to be known as a entity or a record, which consists of all the necessary data, relevant data needed for the particular attribute or particular entity. Okay, here one unique ID will be there per table. Okay, so that unique ID will be represented as a primary key. Okay, so in some cases, if there is no particular ID or if there is no particular unique ID, then what will happen? If so what will be the situation, or what will happen if there is no primary key? Okay, any idea? So if there is no primary key in a database, then what will happen? What will happen is, instead of a single unique primary key, they will select two random composite keys, which are not unique. Okay, so instead of a single key, they will be using two keys, which is a composite key, which is called as composite key. Okay, so this is about the database, records, entries, tuples, everything, etc. Okay, so next one, this is another example where tables is also called as a relation. Okay, these were the diagrams which I meant to show in the last tutorial, last webinar. Okay, so this is also another example how a database is being given, and here customer ID can be given as a primary key, a unique one. And then we have seen what is a relational database and what are the various terms which are available in the structured data model. Okay, so in relational database management system, actually there are several databases available, database management system available, but in particular, relational database management system is very, very important in this GIS data field. Okay, and one more thing is, relational database management system doesn't work upon images. Okay, it doesn't work upon images. So what is being done is, this relational database management system has to be working perfectly. So what they have done is, they have converted the images into tabular column, and that tabular column is being applied with relational database management system. Okay, so this is the best working prototype so far for us. And in relational database management system, these are the three components which we are going to see. The first one is primary key and foreign key. In primary key and foreign key, we have seen in the last class. I will show you with an example also now. So this is actually an example of primary key and foreign key. Okay, so let's assume the table 1 and table 2. Okay, so in table 1, yes, security number. Okay, that is a unique ID generated for each entity. Okay, so that is a very unique, and that is taken as the primary key. Okay, and whereas in the second table, okay, order number. Okay, the order number is taken as a unique ID, which is taken as a primary key for that okay, for that table, okay, and also we are having another number, employee number, which is also unique, okay. So that employee number is also unique, and that can also be a primary, a primary key. So that employee number is taken as a foreign key to another table, the first table, okay. So employee number is a unique column acting as a foreign key in the first table, okay. So this is how a primary key and then a foreign key works upon. And in case if there is no primary key, we know that we will be selecting two random composite keys. Those keys are called as composite keys. Instead of a primary key, we will be selecting a composite key if there is no availability of a primary key. Okay. So this is one example. We have also seen another example. Okay, we will go on to joins then. So joins, there are actually several types of joins. Okay, so there is these joins are used when we are merging or we are combining multiple tabular columns together. Okay, so when we are combining multiple tabular columns together, there is obviously overlapping of data. Okay, so when there is a overlapping of data, how to filter those data, that is being done with joins. Okay, so like for example, there are basic two types of example two types available in joins. One is inner join and another one is outer join. Okay, so in inner join, the common records in both the tables are being displayed. Okay, so there is no any segregation and all. So here what has been done is the records which are common in both the tables is being displayed in this process. That is inner join. Okay, JOIN. Okay, and the next one is outer join, where both the common entities are also displayed and both the uncommon records are also displayed. Okay, so both the common as well as uncommon records are displayed. Okay, so common is okay. So how will the uncommon records be displayed? So that is being divided into two more segments. What is that? Left outer join and right outer join. Okay, so left outer join and right outer join. So what is done is, so left outer join indicates the common data from both the tables and displays the uncommon data from the left table alone. Similarly, right outer join, what it does is it displays the common entities from both the tables and it displays the uncommon data from the right table alone. Okay, so this is inner join, outer join, and left outer join and right outer join. Okay, so the next one is normalization form. So in normalization form, we have seen several normalization form like UNF, which is unnormalized form, 1NF, 2NF, 3NF. Then it came BCNF, 4NF, 5NF, 6NF, and several normalization forms are there. But the key point of using a normalization form is to reduce the data redundancy or to completely eliminate the data redundancy. Okay, so that is a very key point. And this is another example of how we are scrutinizing the databases. Like in first internal GIS database, you can see that there are entries A, B, C, and B again. There's a repetition of B again with different data. So when they are transferring it to the external database, they are combining those things into a single entity. So this is data redundancy process. Okay, they are trying to avoid or trying to eliminate the data redundancy completely. Okay. And after relational database management system, we have gone to the next segment, object-oriented database management system. So in relational database, there is it is the best option we have, but the only problem in relational database management system when compared to OODBMS is the coding part. So when we are trying to elaborate or expand the coding part, all we have is a single query which gives the answer for the entire question. Okay, but whereas in a coding part, object-oriented DBMS helps us in a better manner, and it almost helps us to fill the entire program in easier way. Okay, like for example, object-oriented databases uses UML diagrams such as class diagram in order to represent the data. Okay, so in class diagram, everything is object. Okay, so every object is being represented by a rectangle. Okay, so in a class diagram, okay, the class diagram is segregated into three segments. So this is actually an entity diagram where it is a combination of the salesperson and department and the address of those three entities and attributes and decision making together. You will see this later. This is the complete database model. Okay, so we will first finish this one. So in object-oriented databases, what will happen is in a class diagram. Okay, in a class diagram, the table is being segregated into three segments. So the first column will be the name of the table. The second column will be the various attributes that has been implemented, and the last table will be last row will be the operations or the methods which are being used in the class. So with the help of UML class diagram, OODBMS is being functional. Okay. The main advantages of this OODBMS is that it can be converted to a coding part very easily when compared to the RDBMS process. Okay. So this is so far which we have discussed, and this is an overall process how a data is being converted. So the first image is a real world image, and the spatial data is being taken and it is being shown as an analog map in the second diagram. And the details from those real world analog map is being taken, and those details alone is being produced in a simple example manner. Okay, and those details is being tried to modify it into a database process. Okay, so the shape, the node, the polygon shape, everything is being given in a database structure manner, and finally a unique code is being represented in order for the final output. Okay, that is how a digital representation is being taken place. Okay, so this is one example, and now we are moving on to the RDBMS versus OODBMS process. Okay, the difference between the two. Okay, so these are the two models which we have seen so far, and obviously RDBMS is a table-oriented model, and OODBMS is object-oriented model. The expansion is relational database management system, and obviously object-oriented database management system. Now, what are the common differences? That the RDBMS was introduced by EF Cord, okay, and a database management system in which the data, this is RDBMS, which has been introduced by EF Cord, and whereas in OODBMS, okay, a database management system in which the data is being represented in the form of object as used in object-oriented programming. Okay, in programming language, when we are converting these UML class diagrams into a coding part, then we are inventing or when we are implementing OODBMS process. Okay, and the fourth point is that in RDBMS, it handles a very simple data, and whereas in OODBMS, it can handle a huge variant of data. Not only a single data type, multiple data types can be used. Okay, so far in this four types of difference, we can see that OODBMS is more handling data, and it is also easier to convert the code. Then why we are choosing for RDBMS? Okay, that we will see in the next slide. So in this slide, you can see that how RDBMS is more efficient. RDBMS is simple as it stores data in tables, that is rows and columns. Okay, but whereas in OODBMS, structure of data is complex. Okay, as we are handling with several types of data. Okay, so the structure differs and it is very complex when compared to RDBMS. So that's why we are going for relational database management system in GIS. Okay, in Geographic Information System. Okay, and normalization is used to eliminate data redundancy. Of course, normalization, we have seen how many types of normalization are there, and it is the main purpose of normalization is to avoid or completely eliminate the data redundancy. And how are data redundancy taken place in OODBMS is that they are using inheritance and encapsulation. So there should not be repetition of data. So what they are trying to do is they are using the data from their parent classes. So from their parent classes, they are trying to invent those functions in their classes too, so that data repetition will be avoided, and unique data with the inheritance, we will have multiple security and privacy also. Okay, and some common examples for both the databases are MySQL. Everybody should have heard. MySQL and Oracle are one common databases which is being very popular in today's world. And MS SQL is also another example for RDBMS. But whereas in OODBMS, Versant Object Database, there is one tool like that, and Objectivity DB, and Object Store, Cache, and ZODB. These are some examples for object-oriented databases. You can note this down later. Okay. So that's for the revision today, and we will move on to the first topic of today's session, ER diagram. So we will be seeing what is about ER diagram, what are the shapes, why we are using ER diagram, what is the relationship between two entities, everything we will see, and then we will move on to the next topic, spatial data models. And after our 1 hour session, we will complete today's session by 11:30, and we will be having your unit 1 test from 11:30 to 12. Okay. So starting with our ER diagrams. So last class we have seen what is the basics of ER diagram. ER diagrams are nothing but entity relationship diagrams. Okay. So entity relationship diagrams in the sense here, let's assume if I am an entity. Okay. If suppose Karthikeyan is an entity, then what are the attributes that can be given as a, so if Karthikeyan is a teacher, okay, he is a teacher. Okay. So that is one attribute given to that entity. Okay. And if suppose there is another entity like that, then what is the common relationship between both entities? So teaching profession is a common entity between, common relationship between both the entities. So likewise, we are including all the objects in the given picture and then giving a relationship diagram. Okay. So the relationship between the entities is represented in a diagram. Okay. So for a diagram, we can't just draw a free sketch or anything like that. So those diagrams have some rules. Those like for example, the shapes which indicate separate meaning for every entity, and the line, even the lines getting connected. Okay. So one to many, many to one. So there are several options of lines available in the CR diagram. So we will, even though you guys have seen those things in the your database management system, we will just have a quick glance of it. Okay. Okay. So this is actually an entity which has been represented in a rectangle. So any common name or any username is being given in this rectangular box. Okay. So this rectangular single line rectangular box indicates that it is a entity. Okay. So there are two options. There are two kinds of entities. Like one is a weak entity and one is a strong entity. And a weak entity is that which must be defined by a foreign key relationship with another entity, as it cannot be uniquely identified by its own attributes alone. Okay. So when we can't find the necessary entity which we are looking for based upon its own attribute, then we will be using one foreign key relationship in order to identify those entities. So that is called as a weak entity. So a weak entity is given with a double lined entity, rectangular shape. Okay. And the next one is a relationship diagram which represents a diamond shape. Okay. So in programming language, in a flow chart, actually a diamond represents a decision making statement. So here a diamond shape represents a relationship between two entities. Okay. So what are the operations, or what are the relationship that both the entities are having? Okay. Like for example, if student is one entity, okay, and the class is another entity. Okay. So what is the relationship between a student and the class? Of course, attendance. Okay. So the relationship between a student entity and a class entity is nothing but attendance. So if we are drawing a ER diagram, then one rectangle will be there on the left, one rectangle will be there on the right. So one is student and one is class, and this relationship will be attendance. Okay. And below shown is an example for a self-linked entity model. And the next one is coming for our attribute data types, which is attribute, which is represented in a single lined. There are actually three types of representation of these attributes. If we are representing an ellipse format in a single lined continuous line circle, line ellipse, then it is a normal attribute. Okay. If it is a multi-valued attribute, then we can have, it means that there is more than one value available for that. Okay. So if it is a multi-valued or multi-skill value, then we will be implementing a double-lined ellipse. Okay. So first single-line ellipse is a normal attribute. Like for example, in previous example, we have seen student, attendance, and class. Correct. So what will be the ID or what will be the attributes of those class and what will be the attributes of those students? So, so the example will be for class, it will be a class ID and description. Okay. So class ID will be a unique ID which is acts as a primary key, and this description will be any other attribute. Okay. So class ID and description, these are the attributes of a class entity. Correct. So whereas when it comes to a student, okay, when it comes to a student, what will be the attributes? It will be a student ID, a student name, or an address or a class ID. So these things will be given as the attributes of a student entity. Okay. So when it is a multi-valued attribute, then we will have a double-lined ellipse. Okay. So this is what attribute is about. And a derived attribute is based upon another attribute. So when we are deriving one attribute from another. Okay. So how can I say? Like if we are giving an average or a total marks, if we are getting an average of 3 marks, average of 3 subjects of a particular student, then that average mark depends upon 3 other values or 3 other attributes. Correct. So in those cases, we will be using a dotted ellipse in order to mention those attributes. Okay. Dotted ellipse in order to mention those attributes. Okay. And here the example given is an employee's month salary is based on the employee's annual salary. Okay. So based on so this attribute is related to that attribute. So the employee's month salary will be given in dotted ellipse format. Okay. So those are doing connecting lines. Okay. This is a very normal example of ER diagram. And there are many lines and you can see many edges available. So we will see what are the meaning of those edges and lines available. Okay. So a straight line, it means that it is a one-to-one process. Okay. A straight line means that it is a one-to-one process, and it is a normal line or normal which is being implemented in almost all the ER diagrams. Okay. And in the second line, you can see over here, if you can see the mouse pointer. So in one-to-many, if it is the left-hand side is given as 1, okay, and the right-hand side has given a multiple option, then it is called as one-to-many. Okay, so one-to-many. So this option is called as one-to-many. So this is a one-to-many situation. Okay, from this diamond box to this customer, this is a one-to-many situation. Okay, and from left-hand side to right-hand side. Okay, we are not mentioning any bar over here. So this is many. This indicates that there are many options available from left-hand side. It doesn't mean that it is going to reach the destination in a single entity. So this is not many to one, but this is many. Okay, and the next one is one or more, mandatory. Okay, this is either one or more. Okay, so it means that from the first company or the employee, it may be many employees or a single entity. Okay, so this process is given over here. It's better for you guys to understood all the lines and functions in order to draw a particular ER diagram. So let's see again. The first one is one-to-one, second one is one-to-many, and the third one is many, and the fourth one is one or many. Okay, and the fifth one is one and one only. Okay, so it means that from the left hand side to right hand side, only 2 entries have been connected, and only those 2 entries have been working together. Okay, and the next one is 0 or 1. These diagrams are very rarely used in those ER diagrams in today's scenario. Okay, and 0 or many optional. Okay, so these are not mandatory segments, these are just optional. And Okay, there are few styles of data given in these edges itself. Like there is one is Chen style, and another one is Batchman style, and another one is Martin style. Okay, so these are the three types of styles available in this engineering style format. Okay, so you better note these. I hope everybody is taking running notes and noting down few important points, because these points will be asked in your Unit 2 questions also, multiple choice questions. Okay, so the first one is Chen style, the next one is Batchman style, and other one is Martin style. So these are nothing but various types of data representation which is given with in according to entity diagrams. Okay. So when I see you send you these PPTs, you can just refer to all the techniques available. Okay, and what these dotted lines mention and what is this hollow circles mention, everything you can go through. Okay, so the same techniques only, but here we are using a straight line as 1 to 1, but here a dotted line mentioning one point to another point is mentioned as 1 to 1 over here. Okay, and 0 or more to 1, 0 or more to 1 or more. So that is being indicated with a white color circle started with left hand side and pointed towards a arrow mark in the right hand side. Okay, so these are Batchman style, and the last one is Martin style, where 1-1 and one only. Okay, this indicates if 1 means 1 and 1 only. Okay, if star here they are trying to use integers and operators in order to mention those segments. So everything is being marked with a straight line only. But with the straight line, we are also marking with several elements like integers or asterisks or operators in order to represent the meaning of those relations between the entities. Okay. So what are the uses of the ER diagram? So ER diagram gives us the overall picture of the spatial data type. So that is the ultimate aim. Okay. So ER diagram actually gives us the relationship between the entity and from where the data is being scrutinized, and which is the primary key, which is the foreign key, and what relationship is there between two entities. And not only two entities, here we are not dealing with one or two entities, here we are dealing with n number of entities. So when we are looking at a ER model with almost hundreds and thousands of shapes and structures, okay, and it will give us a clear picture. Even though we are using multiple shapes and structures, it will give us a clear picture that what relationship is there with another entity, and what are the attributes of those entities, okay, and how it is being connected. Everything will, what is the weak entity, what is a strong entity, what is a multi-valued attribute, everything will be shown clearly, even though if we are using multiple shapes and sizes in a single ER diagram. Okay, so that is one main advantage, and it acts as a huge documentation process, rather than explaining the complete spatial data structure or data model in detail. Okay, so this will give us a very simplified and accurate data for this documentation process, and it acts as a very helpful tool to convert the data or to analyze the relationship between the data in a relational database management system. Okay. Okay, this is a normal process of how ER diagram actually works. Okay, so we are selecting any two random entities. So in this case, let us take one entity is student or another entity is class. We can also have two more entities like lecturer or subjects. If we are having four entities also, that's fine. So as RDBMS is capable of managing multiple amount of data. Like so now, in order to be simple, we will have two entities. One is student and another one is lecturer. Okay, we don't want class, we will have student and lecturer. We will have two entities. So the first entity is student and the second entity is lecturer. Okay. So first we have to identify those relationships. So what is the relationship between the student and lecturer? It is a teaching process. So teacher is a relationship between the student and the lecturer. So a lecturer is a teacher for that student. So that is the relationship, correct? So now after identifying the relationship, we have to describe the relationship first. Okay, so after we are describing the relationship, we have to give the metadata, data about the data, and then we have to add the attributes. Like already we discussed, the various attributes for student entity is student ID, student name, and address. Okay, so that is for one. And if you want to add means, you can add class ID also. Okay, so let's assume there are four attributes for the first entity, student. And what can be the attributes for a lecturer? Lecturer ID, lecturer name, class ID, and subject ID. Okay, so here this class ID is common in both student as well as lecturer. Okay, so here we can, if you want, we can take it as lecturer ID as the primary key, and class ID as a foreign key from the class entity, which is common in both student as well as in lecturer. Okay, so the attributes given for lecturer is lecturer ID, lecturer name, class ID, and subject ID. Is that clear? Okay, and these are the attributes, and the complete diagram is there should not be any leftovers, or there should not be any blank. There should not be any island particles. Like island particles means everything should be connected, and there should not be any island kind of data missed everywhere. Okay, so all the entities have been connected with lines and diamond shaped relationships, and everything is being described with the help of their attributes also. Some may have multiple relationships, even that is also okay, not an issue. Okay, so so a complete diagram represents should have all the entities, attributes, and the relationship between the entities. Okay, so with this we are completing with the first topic of today's session, which is ER diagram. So this is how an ER diagram works upon, and the various shapes and structures you would have gone in detail in a DBMS subject also. In last class I told you that there are several types of attribute. I will tell you in the next class. And just to mention you guys, the various types of attribute are simple attribute, composite attribute, derived attribute, single valued attribute, and multi-valued attribute. Okay, so totally there are 5 types of attributes available. Okay, so in the 5 types of attributes, a single attribute, composite attribute, derived attribute is what we have seen so far, the dotted line, dotted elliptical shape, and then single valued attribute and multi-valued attribute, everything are types of attribute represented in different format. Because we know that every attribute is not of the same type, and some can be complex, some can be simple, some can be derived from another, some can have multiple values also. So based upon the values, based upon the attributes, the shapes are given. Okay, and what are the advantages? If you ask me, it makes the requirement simple. Okay, and it is easily understandable by representing in a simple diagrammatic manner. So that is the advantages of this process. And another one is one can convert an ER diagram into a record-based data model very easily. Okay, so a ER diagram can be represented in a record-based data model very easily. So that is one main advantage of this ER diagrams. Okay, and the most important advantage is that it is very easy to understand. The relationship, the entity, how many attributes are there, how many entities are there in general. Okay, rather than looking for all the data without knowing anything, we can directly go for looking for the entities itself, so which will give us clear picture. So the ultimate advantage of using a ER diagram is that it is easy to understand ER diagrams, and the second advantage is that the ER diagrams can be easily converted into a record-based data model. That is what it is necessary for us in this GIS protocol, this database. Okay. But similarly, it has some disadvantages also. Okay, so these disadvantages in the sense there is no actually proper standard notations available for ER diagrams. Okay, there is great flexibility in the notation. It all depends upon the designer only, how he draws it, and how. So designer is nothing but we the people are the designers. So if we are going to draw the diagram, it is based upon us to how complicatedly we draw the diagram or how simple we draw the diagram. Okay, so that is the disadvantages of this ER diagram. And one more disadvantage which can be mentioned is it is it's actually meant for high level designs. Okay, we cannot simplify for lower level designs like coding and all. So that is also one disadvantage for ER diagrams. Okay. So with this, we will wind up with the first topic, ER models. Okay, and students, if you have any queries, kindly post your queries in your chat box. If you have any queries in this first topic, please post your doubts in your chat box. Any queries? Anybody? Any doubts? Okay. So now we will move on to the next part. So before moving on to the next part, we will look for the solution for the puzzle which is given to you in the first section. Wow, immediately I got the answer. Okay. Actually, the question is only mastermind can solve this, but I can see several masterminds available here. Excellent. So Leelavati has the patience to type everything clearly and she was waiting for me to give the answer, I guess so. Hariharan, Leelavati, Sainath has initially given the first equation alone. Sujita Shri, Sandhya Rani, good. Selvi, Shenbaga Priya. Okay. Anybody else? Come on, students, I want everybody to respond. Be a part of this. Anjali, okay, type everything clearly. Excellent, ma. Soumya, good. Very good. But you know, there's always a twist in your answers, right? In these kinds of questions. Okay, let's see. Sharon, good. Uma Devi, good. Good. Hemati, good. Come on, that's all. Anybody else wants to give the answers? Mm-hmm. 13 students replied so far. Good, very good. The active participants in everyday session, these 13 students. I really appreciate them. And some more students, I have seen names of few more students also. I think they are still typing. Okay, so we will then, okay, Gautam, good. Okay, so now we will move on to the solution of this question. Okay. And the answer is, as everyone has perfectly given, the answer is correct. 7, 9 and 19 and 7. That is exactly correct. So I can see excellent masterminds from these classes. Congratulations, students. Thank you for participating. And now the first session is over. We will move on to the next session, okay, which is spatial data structures model. Okay. So here we will be seeing, as in the first slide, I have shown you the different types of data structures. Okay. We are now going to see how the data structure is being related with these data models. Okay. How these data structures and data models are related together. So data models are nothing but they are basically a conceptual representation of the data structure. So what is conceptual means? Conceptual means graphical representation. Okay. So data models are graphical representation of those data structures in a database. Okay. So ultimately, in a GIS program, we know, GIS procedure, we know that a query will be given, data will be collected, analysis will be made, and finally output will be given. Okay. So those analysis part is what we are dealing with here right now. So in those analysis part, we will be seeing what is a database, and in order to see what is a database, here data model and data structure is very, very important. Okay. So here we are going to see a raster data structure as well as spatial data structure in this unit. So the first one is spatial data structure. So spatial and non-spatial data structures. So in spatial data structures, we have two types of data models. One is vector data model, another one is raster data model. So we know that vector data model means it is been representing the spatial data by means of points, lines, and polygons. Okay, and whereas raster data means representing the data in XY axis or through grid format, where grid format is arranged in a cell aligned format, and each cell consists of the data of that particular cell alone. Okay, so we are moving on to the spatial data structures model. Okay, so in spatial data structure model, when we are combining or when we are converting a real-time spatial data into a graphical data. So what are all the components which are available in spatial data? Either it should be a natural object or it should be a man-made feature object. Okay, correct. So natural object in the sense rivers, land, mountains, trees, etc. will be natural objects, correct. And man-made features are highways, bridges, roads, okay, and tunnels, and subways, buildings, colleges, etc. So those are man-made features, okay. So these natural and man-made features, how are they being represented? Okay, so actually they are represented in three various stages of data. Okay, like one is conceptual data, conceptual model, another one is logical model, and another one is physical model. Okay, here what happens is the conceptual model is converted into a physical model by means of a logical model. Is that clear? I repeat, the conceptual model, there are actually three stages of representation of those data, which is of natural and man-made features. One is conceptual model, another one is logical model, and another one is physical model. Okay, so what happens is the conceptual model is being converted into a physical model by means of a logical model. So through logical model, the conceptual model is being converted into a physical model. Okay, so this acts as a very, very important stage in spatial data structures model. And these are the three types of data models which we are saying: conceptual, physical, and logical. Okay, so from conceptual it goes to the physical by means of a logical. Okay, so what is a conceptual model? Okay, it is a process, like I said, it is a graphical representation from the real world. Okay, so it is mostly human oriented and partially structured process. It determines the aspects of the real world to include which all to be included and which all to be excluded can be decided in this segment. Okay, so that is about conceptual model. Okay, and next one is logical model. Logical model is based upon its name, it gives us a meaning. Okay, it is an implementation oriented approach. So when we are implementing only, we will know that whether that logic is correct or not. So likewise, so it is a representation of reality in the form of diagrams and lists. Okay, so in reality, if this is possible or this is sustainable, this data can be converted into a database entity. That is all being discussed in this logical model. So that's why when we are implementing only, we can decide in these things. So it is an implementation oriented approach. Okay, and the last one is physical model. Okay, so in physical model, it actually represents the actual implementation in the GIS environment. Okay, so in geographic information system environment, it comprises a table which are stored as databases actually. Okay, so physical model has specific implementation approach only. So from conceptual model through logical model, first they are creating the graphical representation, how the spatial data has been converted in a graphical manner, and then from that graphical representation, due to logical model, few relevant and irrelevant data has been added and taken away respectively, and finally the output data is being given in the database format through physical model. Okay, so this diagram represents everything for us. So in a reality, the real world features are available. So from that, we are converting it into a conceptual model. And the next ellipse, you can see that from conceptual model, we can taking it to a logical model. So after the filtration process done in the logical model, finally we are giving the physical model. Okay, so from human oriented aspect of real world, we are going to computer oriented aspect of real world. So this is spatial data structures model. Okay. So again, the main aim for the conceptual model is to establish the entities, their attributes, and their relationship together. It's similar to an ER diagram, a diagrammatic representation. Okay, and there is also in spatial data model. Actually, there is two types of representation of spaces available. Okay, there are actually two types of spaces available. Actually, one is a discrete entity, another one is continuous field. Okay, we will see that in upcoming slides also. Okay, so here in spatial data models, we are going to see what is the conceptual model, logical data model, and physical data model. Next, we will be seeing what are the two spatial data models, which is very, very important. One is raster data model, and another one is vector data model. Okay, so we will see that raster and vector in next slide. So this is a combined example of conceptual, logical, and physical type. So first one, the participant is the name of the complete segment, and here in logical segment, we are giving just the logical idea. Like for example, in conceptual, we know that we are going to give a participant in this database. Okay, so first one, we are converting the real-time data as a participant, and then in second one, logical, we are using the logics. Like logical means the participant ID, the participant last name, and the participant first name. These are the entries which we are creating in the logical segment. Okay, and look at the last part. In physical segment or in physical, what we are doing is, as you should have known, what is an identifier. Okay, identifier is a keyword, or it is not a keyword, it is a variable which has few set of rules. Okay, so based upon those rules, we are using proper programmatic system like underscore. There is no spaces allowed, so everything from the logic statement is being purified to a programming language segment. So participant underscore ID underscore integer is a single identifier, and it is not three names. Okay, so these are the filtration or the purification process. Rather than purification, we can say that it is a segmentation process. Okay, so from the real world conceptual model, we are converting it to the logical model, and then finally we are getting the physical model. Okay, this is also another UML class diagram exemption. So here how conceptual is being taken in two cases, as logical and as how physical is being taken place. Okay. Okay. So now this spatial data structure model. Okay. This spatial data structure model is being segregated into two models. Okay. So one is object-based model, and another one is field-based model. Okay, so I will tell you what is object-based model and field-based model. Object-based model is nothing but vector-based model. Okay, so vector data model is called as object-based model, and field-based model is called as raster data models. Okay, so you can assume it as R for field, like Royal Enfield is there, right? So you can keep that name for remembering it. So field means Royal Enfield. So R field, R means raster data. So field-based model means it is actually raster data model. And object-oriented model means vector. Vector, what example? VO, village officer. Okay, so object-based model means vector-based model. Okay, and field-based model means raster-based model. Okay, so this is how a normal raster database model and vector-based model works upon. So the first topmost root node is a real node, okay, or in the real world. So that real world is being represented both in object-based model as well as field-based model. So you can see the grid shapes in field-based model. So grid shape actually represents the raster data format, correct? So in raster model, so those data are being combined together in sampling locations and given the final output as a raster model. Okay, so there are, and similarly in object-based model, we are representing in terms of points, lines as well as polygons. Okay, so those object features are being combined to as a vector model. So object-based models are represented as vector data model and field-based model are represented as raster model. And finally, for spatial database, both vector model as well as raster model is being combined together. Okay. There is also some conversions available, like you will be coming up across few terms called as interpolation and interpretation. So interpretation is interpreting the data from one to another. Interpolation means we are combining the data with one another. Okay. So retrieving the data from one another and combining the data from one another is the interpolation and interpretation. You will see that in the upcoming slide. So this is object-based model only. So this is object-based model, actually the vector-based model or vector data models. Okay. The vector data model is closely linked with the discrete object view actually. So in vector data model, geographical phenomena are represented in three different forms, like points, lines, and polygons. Okay. So the shape of a spatial entity is stored in using a two-dimensional XY coordinate system. Okay. So this we have seen several times in the first unit itself. What is a point? What is a line? What is a polygon? And how it has been represented. Okay. But the thing is, the same point, line, and polygon can be represented in a raster data model also. Okay. So, but in the format of a grid structure, a cell by cell structure. Okay. So that's how a representation of points, lines, and polygon given in both a vector model as well as in a raster model. Okay. So whereas in the field-based model, okay. So in spatial phenomena, it may be organized as field, which are obtained field in the sense the single attribute column that they are mentioning in the database is direct or indirect source. Okay. Okay. So now we are coming on to raster data model. So raster data model is commonly associated with the field conceptual model, like we have seen the previous slide. Here in geographic space, it is represented by arrays of cells or pixels. Okay, by cells or pixels. Okay, so if we have like a chessboard with everything in white color, okay, a white color chessboard, completely white color chessboard. If we want to mention a point which is available in the vector data, if we want to display that in a raster data, so that point cell alone will be highlighted in black color. Okay, so remember a white color, completely white color chessboard with one cell alone in black color. So that is how a point is being represented. Okay, in raster data model format. And whereas a combination of several cells together, highlighted cells together indicates a line. It may be a straight line or curved line, that doesn't matter, but a combination of several cells, when several cells are highlighted together, whether in adjacent manner or in diagonal manner, then also it is called as a line only. When few cells, adjacent cells are colored together or shaded together, then it is a polygon. Okay, this is how the data from point, line, and polygon have been mentioned in a raster format. Okay, so how what are the things they are going to mention is if there is any exact location, we can mention it as a point. If it is a river or it is a highway road, we can mention it as a line. And if it is a particular polygonal structure or area, we can mention it as polygon. Yeah, this is one example. If it is a line, we can mention the entire cell in a shaded format itself. So one rows and one column, it is identified like this one. The shaded part gives us the column indicates the field and row indicates the record of an entity in this database. Okay, this is how raster data model works upon. Okay, this is also how this is what exactly I told. So if in right hand side you can see three dots are there, so how these points are available. So in left hand side you can see that one white sheet or one white segmentized sheet. Okay, in that segmentized sheet only 3 points have been highlighted. So those 3 points are nothing but representing the points in a cell structured manner. Okay, And the next one is a curved line, which is it can be a road or it can be a river or anything. So those shaded cells are connected together in diagonal format, not in adjacent format, but in diagonal format in order to give that representation. And in third segment, the polygon is given as a combined adjacent shaded parts. Okay. So this is how the representation of point, line, and polygon features are given in raster format. Okay. So finally, the left hand side is a raster format and the right hand side is a vector format. Okay. Now coming on to the next topic, what is a cell value? Okay. Actually, cell value is nothing but it can be either a pixel value or a particular cell from a raster grid format. Okay. So these cell values, these entity models, these file structure, everything comes under raster data structure actually. Okay. So before going into that raster data structure, we will see the advantages and disadvantages of these vector and raster data models. Okay. Was for the vector data model. Okay. So after that, we will see the raster model. Okay, no problem. Okay. So the pixel value for the full image will actually be shown. Okay. So if, for example, if there is nothing available in that pixel, the value will be 0. If something is available or if that value is being shaded, then it will be 1. Like for example, in this previous diagram, you can see that except the white areas, only the 3 dot is being mentioned over in black spots, right? So what will happen is all the gray area in this place, the first image, can you see my mouse pointer? So in this first image, all these values in the gray color area will be of 0 value, okay, which is not being shaded. Okay, and these 3 points which is being shaded, these 3 cells alone will be having the values as 1. Okay, so what will have be the values? The first row will be completely 0. The second row it will be 0, 0, 0, and then 1 for this cell alone, and then completely 0. Is that clear? So this is how the value, cell value is being represented. So here also in this particular second image or in third image, the shaded part is being given as a value 1 and the non-shaded part is given as a value 0 in case of binary informations. Okay, the shaded part is the unshaded part. Okay, so here they are categorizing the cell value in a raster data model. Okay, so a land can cover like for example, if it contains any categorical data within one urban land to use, or it can not only in the binary format of zeros and one, it can use multiple values for its own. Like for example, 1 for the urban land, 2 for forest land, and 3 for water resources. So they are using 3 types of values in a cell structure in a grid raster database format. Okay, so wherever it comes 1, we should understand that it is an urban land. So wherever it is 2, you should understand that it is a forest land, and wherever it is 3, you should understand it is a water body. Okay, so these are the 3 types of cell values, basic cell values, which we can implement in a grid or raster data model. Okay. So the value which we are assigning upon, it can be either a complete whole number integer or it can be a floating variable also based upon the area space. Okay. So this is how a cell value is being indicated, and each cell will be having a detail about that particular area alone, right? So that is being mentioned with the cell value. So we cannot say it is the cell value is a cell ID, but it has a value in order to which retrieve the data of those cell values. Okay, those data about those cells alone in a single cell of the grid or raster data model. Okay, and cell size. In a raster grid model, we can see that the cell size is being equally divided in from the first unit cell to the last unit cell, but the less amount of value or the less amount of area space we are covering in a single cell. It can be either 10-meter raster data or a 30-meter raster data or even higher. The more lesser, the more clearer the data will be. Okay. So this is the cell size. There is also been mentioned by the end users only. So the cell value which is being assigned by the user is also taking charge of the size of the cell. Okay. So it means that if you are, for example, covering a 3-kilometer radius in a single cell, and if in another data example we are covering a 30-meter distance in a single cell, then what will be more efficient? Obviously, the 30-meter raster will be the more efficient, because the more lesser the area will be, the more clearer or the more precise the pixels will be. I hope you guys remember in first unit in one webinar I have shown the various representation of a character A, okay, and the total number of pixels. As the number of pixels increases, the clarity and the quality of the image increases. Okay, so as the cell size is smaller, as the cell sizes are smaller, the data precise will be more efficient and higher. Okay. And if there is any other problem, those problems will also be reduced when the raster uses a smaller cell size. Okay. And the next term is the cell depth. Okay. The cell depth of a raster data, it actually refers to the number of bits of storing cells per value. Okay. A bit is nothing but short for binary bit. So one binary bit is actually a 0 or 1. So 0 or 1 in general, it indicates that 0 is there is no value in that one, and 1 indicates that there are values in that particular cell. Okay. So a byte is nothing but a combination of series. It is a sequence of bits. So 1 byte is equal to 8 bits. Okay. So with 8 bit equaling 1 byte, higher cell depth means that the cell can store a wider range of values. Okay. Like for example, we can have an 8-bit or 16-bit or 32-bit character. So if 8-bit means it can store up to 256 data. Okay. So whereas in 16-bit means again it has it can store up to 65,536 possible values. So this is what we are calling it as depth. Cell depth means the memory space which can withhold that particular cell. Okay, or the memory space that particular cell can withhold. Okay. So these are raster bands. Raster band are in the sense like we have seen a spectrum diagram, right? Spectrum diagram is a color combination. If you are selecting any colors, if you are selecting other color option means, then what will happen is from one color series to another color series, you can see n number of color combinations. Okay, not a particular color, but a various transaction of color. So that is what called as a spectrum band. But here in raster band, what happens is that they are actually using 3 band structures. One is red, green, and blue. Okay, the basic RGB format. And there is also another model called as DEM model, which we have seen in the previous unit example. Let's see whether it's not. So DEM diagram, I hope you guys remember that one elevation shown from an average sea level to the height of the mountain. Okay, so the height and depth of a mountain is being identified with the help of an average sea level. Okay, so that model is called as DEM model, that is digital elevation model. So where the digital elevation model can be represented with the help of a single color, one band color. Okay, holding any elevation values. For example, it can be any color, any red color or green color or blue color. But whereas in raster branch, it can be of any color. If it is a purple color is nothing but a combination of red, green, and blue. Correct. So a equal coefficient of red, green, and blue gives us a purple color. So that is what a raster band combines. So raster band uses three types of band, RGB color bands in this raster band in order to represent the data. Okay. So an example for multi-band raster is that it is a satellite image which can have up to 5 or 7 or even more bands at each cell location. Okay. So as it is a satellite image, each cell will be having various color combination. It can be mostly brown colors and blue colors for waters and green colors for grass. Apart from these colors, and so these colors are not just direct colors, right? These colors are also combination of several colors together, right? So based upon these color combinations, the image will be shown through a satellite image. Okay. These are raster bands. Raster bands are nothing but the color band which is being used by the raster data model. And the spatial reference. Spatial reference is nothing but the coordinate system, either geographic or this coordinate system. So in this coordinate system, what we are trying to do is either it can be a cylindrical point of view or a conical point of view or a planar projection point of view. We are referring that geospatial data into this reference. Okay, so this process is called as georeferenced raster process. Okay, a raster that has been processed to match a projected coordinate system is often called as a georeferenced raster. Okay, so these are about the spatial references and the details based upon those spatial data is being given in the spatial references also. The metadata and the exact locations, the coordinates, and the depth and height of those data. These attributes are also given those spatial data. Okay, and this is how a match raster match a projected coordinate system actually. Okay. And of course, UTM is being used. UTM, I hope you guys remember, Universal Transverse Mercator. So it means that rather than giving all the individual countries to generate their own latitude and longitude, uh, we are having a unique universal mentioning of those XY coordinates. So from whichever part of the world you are calculating the value should be precise and exact. So that is universal transverse Mercator. And according to that, if suppose we are having 463 columns and 318 cell size, okay, then the size of or width of a single cell will be 30 meters. Okay, so in an XY coordinate, the lower left corner will be having these values of 4,99,995 or something like that. So these are the lower right values and upper right values will be upper right corner value will be having. So these are the pixel cell size structure of a XY coordinates. And we can also verify these numbers using those UTM coordinates. Okay, so like for example, if you are segregating the low upper limit of the lower left corner and lower limit of the upper right corner. Okay, so if you are combining those two things, then we will get the values. Like for example, the lower value like 4,99,995 is being separated from the upper right corner value, which is 5,09,535, and the final value is being divided by 30. So if it is divided by 30, then the total number of cell size, total number of columns we are getting is 380. And total number of rows, if the same has been done in the right hand side, we will be getting 463. Okay, so this is how we are getting the total number of rows as 463 and total number of columns as 380. Okay. This is also an example similar to that. So with this, we have completed the spatial data models. The next one is vector data model. So in vector data model, we have seen n number of time what is a vector data model. Okay, vector data model is a spatial representation of the data by means of points, lines, and polygons. Yes, so these data are being represented by either in points, points or continuous points or lines or continuous lines, and then polygons will be mentioned in the vector data model. This we have already seen. So this is a three type of representation of points, lines, and polygon feature, and where the cell number third row, second column actually indicates the point, and the first row, sixth cell gives us the starting point of a line, and from last third row, fourth column starts with the polygon shape. These are the representation of points, lines, and polygons in a vector data model. It is actually a space, actually mostly related to the spatial data models only. This is actual image of representation of points, lines, and polygons from a GIS image. Okay, so these are the various themes organized by an individual feature class actually. So the database indicates the various data available in that particular image, and the lines indicates through lines, points, and polygons. Okay, you can see the various points. Points are represented in green color, polygons represented in blue color, and the lines are represented in the pink color. Okay, so this is upon vector data model. And so about spaghetti data model, this we will see it in the next class in detail. Okay, I'll tell you what is it. Actually, spaghetti model is not that difficult, but the spaghetti model I'll have some examples also. So with this spaghetti data model, we will see it in the next class. And with this, we will wind up today's session, second topic. Okay. So after the question and answer session, we will move on to the test. I'll post the link in the chat box. So students, if you have any doubts, kindly post your doubts in your chat box. If anybody has any doubts, kindly post it in your chat box. Okay, so with this, we will wind up today's session. We will start with the test. Nation, sir. Hello. Nation, sir. Radhika ma'am.
சொல்லுங்க சார்.
மேம் டெஸ்ட் ஆரம்பிச்சலாம்.
ஆரம்பிச்சிடலாம் சார். லிங்க் கொடுத்துருங்க.
லிங்க் போஸ்ட் பண்ணுவா?
பண்ணிடுறேன்.
Okay, students, I will be posting the link right now. Before taking up the test, I have few instructions for you guys. Okay, the test consists of 10 1-mark question and 10 2-mark question. Okay, so how I have given is the questions will be shuffled. Okay, for each person the questions will be shuffled and the answer options will also be shuffled. Okay, so please don't try to get the answers from your friends. So they may have a different set of questions and different set of answers, and you guys may have a different set of questions and different set of answers. Okay, so there is 3 segments available in this Google form. The first segment will be your basic data, your name, email ID, and your register number. So please enter those data carefully. The second section consists of 10 MCQ questions. Okay, 10 MCQ questions. Read the questions properly and read the solutions properly and then select your answers. And then the third component consists of 10 2-mark questions. Okay, so in 10 2-mark questions, 2 will be multiple choice questions and the remaining 8 questions will be written type answers. So I want you guys to type your answers in a descriptive manner for those 8 2 marks alone. Okay, at the end of the quiz, you will immediately get the marks. For 14 marks, you will get the total marks. The total test is for 30. Okay, you will be able to see the marks for 14 marks alone. For 14 marks, how much you have got, you can see that. The remaining 8 questions, the 2-mark question, I will give you the answers in the next class. Or after correcting, I will post it in your WhatsApp group itself. Okay, so I will post a link right now. Students, can you see the link? So this is the link for your Unit 1 test in the Geographic Information System. Kindly click the link and take up the test. All the best, students. Please utilize all the 30 minutes. Don't be in a hurry. Do have some patience. Those questions are very simple for you guys. You guys can easily attend those questions. So read the questions carefully and then attend the answers. You can start this test, students. If anybody can't open the Google form or any error or any problem you're having, you can share it with me. Again, I'm saying the test is for 30 marks. After the completion of test, you can see the marks which you have got up to 14 marks. Okay. For the first 14 marks, you can view your score. For the last 16 marks, I will tell you the marks later. The total marks I will give you in the next class. You can take up upon the test. Please don't be in a hurry. Read the questions properly, fill the data properly, and give elaborate descriptive answers for the 8 2-mark questions in a descriptive manner. They have ample amount of time. Please utilize this time in a well proper manner. And students, those who are sleeping and all, I hope you guys are awake and started taking up the test. So thank you, students. So with this, we will wind up today's session. So in next class, we will be discussing the answers for these questions. And we will discuss the answer in detail in the next class. Okay. Thank you, students. Thank you.